Hello friends, my name is Sudeb Dasgupta and I'm a professor in the Department of Electronics and Communication Engineering at IIT Roorkee. It's a pleasure to offer you all an online certification course entitled Cryogenic Electronics for Quantum Computing under the Ministry of Education, Government of India, and we will be using the NPTEL platform for these purposes. So let me thank also the NPTEL platform for sort of democratization of education across India. Let's go through the objectives of the course. Now, the primary reason why this course, the motivation for this course being introduced is with the advent of quantum communication, quantum technologies and quantum computing, there is a big requirement of the sustainable electronics at a very low temperature, around 4.2 Kelvin there, where the qubits are actually sitting. So your all electronics are all based near that. Similarly, when you go to deep space, the electronics works at very, very low temperatures. So the objective of the course is to understand the basics of cryogenic electronics, which is electronics working at very low temperatures, typically around to some orders of Kelvin. The starting of the course will give you an idea about quantum mechanics, which is very, very important at such a course. Then physical behavior of the MOS devices, because that's the mainstay of all the technology which we have at low temperatures, right? So when I say low temperatures, I mean to say we will scale down the temperature from 77 Kelvin to 10 to 4.2 or 4 Kelvin. Now, if these behavior of these MOS devices are known, which are very, very different from room temperature electronics, we need to model these MOS devices for the use in circuits. And these will be modeled using physical parameters. We will also try to explore the cryo-CMOS hardware which are used in quantum computing. For example, if you want to design an oscillator or a low noise amplifier or analog to digital converter right up to low temperature, which is cryo-CMOS, then what technology or what modeling methods or what simulation methods you need to introduce. Finally, which is very, very important, we need to look into variability analysis and sensing mechanisms in cryogenic devices. For example, can we do a noise modeling at such an ultra low temperature, right? Because the variability will be quite an important issue at those low temperatures. Let's come to who will find this course useful, right? I think this course is a very wide range of stakeholders. Primarily, first of all, UG and PG students of electronics and communication engineering, physics, UG, PG, with semiconductor as the specialization will also find it useful for their academic program. And this will be also useful for pursuing higher studies for their master's program. The course will be also useful for practicing engineers of microelectronic industries who are currently or want to work in the upcoming quantum technologies, right? That will be also important for them. And to bring it down to a very basic level, the behavior of the circuits at low temperature will be taken care of, and therefore their influence on the circuit parameters will be also discussed or explained in this course. The organization is very simple, just like any other NPTEL course. There are no prerequisites for this course, but if you have the basic knowledge of basic physics and basic mathematics, and if at all basic solid state physics, typically around second semester, third semester level physics, that will be enough for you to take on this course head on. So there will be 12 weeks in this course. We will spread over 60 lectures, and each lecture will have about 30 minutes. The reason it has been kept small is that it will help you to understand properly, and you can again go back and learn and relearn your concepts. So the course, as I told you, broadly covers study of behavior of modeling of MOS and cryo-CMOS devices at low temperature, and then integration of cryo-CMOS technology in quantum computing and sensing applications. So this is the organization of the course which we plan to do in this forthcoming thing. Throughout the course, the participants will be given regular assignments, right? And these will be sort of multiple choice questions. There will be also live session by certain NPTEL assigned PMRF students. Also, my TAs will be helping you to understand any concepts. I will also try to bring in live sessions where I will also come, where you can throw questions to me. You already have a group. There will be a Google group across which you can drop in your questions and we will be able to answer that. At the end of the course, there will be a certification examination, generally multiple choice questions, which will actually mark your understanding and evaluate so that you can get an official certificate from NPTEL. So with these words, I look forward for you to participate in this course and hope you will enjoy the journey learning through the lecture series. Thank you and happy learning.